All right, we're rolling. Hey everyone, welcome to our mid-year webinar. We're very excited by who we're joined with. Mel Chafart. He is the low carbon buildings lead at CLF HQ, and he's going to give us a very exciting presentation, a deep dive into the CLF HQ embodied carbon benchmark report. And a little bit about Mel. He's focused on data-driven insights into decarbonization strategies and helping practitioners have up-to-date clean data at their disposal to make accurate, impactful design decisions. Prior to joining CLF, Mel was a structural engineer at Bureau Happold, where he assisted in the design of steel and concrete structures in the US abroad and helped to develop internal embodied carbon assessment tools and built out Bureau Happold's portfolio of benchmarks report in the US. At CLF, Mel's recent work includes leveraging Python and other data science tools for the preparation and analysis of whole building LCA tool outputs for the CLF whole building LCA benchmark study and California carbon report. He is also a major contributor to SE 2050's data science team and their work on the SE 2050 database. So with that, as he presents, we can imagine you'll have a lot of questions to ask him. So feel free to drop it in the chat and we'll either answer it as Mel sees fit or toward the end. So feel free to come prepared with questions. And with that, Mel, it's all yours.
Cool. Hey, everybody. I think for questions, if they're like super pressing, can either Sandy or Rochelle just like stop me and say something, but otherwise I'll probably get to them at the end because I kind of just have my one screen here. Uh, Thanks for coming, everybody. There was a lot of acronyms. I realized that bio is very acronym forward. Um, so if there's any questions about that too, please put them in the chat because I know it's a lot of stuff. But today I'm going to be talking about the Embodied Carbon Benchmark Report. Um, uh, the Carbon Leadership Forum HQ is what we're calling ourselves now. Basically, like we are a research team that works on a variety of different, you know, projects uh, in policy and buildings and materials. This is like one of our really big buildings ones. And so I'm really excited to share, which is like basically the culmination of 2 years of work, this report. So let's do it. Okay, so the embodied carbon benchmark report. All right. So I'm going to start by talking about an overview of the project, the report itself, some takeaways from the embodied carbon budgets that I'll explain in a bit, and then some other analysis that we did. And then I'm going to show you guys a cool new dashboard that I've been working on. So that's the plan for today. Okay, so the CLF Whole Building LCA Benchmark Study version 2. Why did we do this? What is it about? What's the reason for it? Um, I think everyone here is gonna understand that embodied carbon is urgent. People are really wanting to know about this. It's a hot topic in sustainability right now, and designers and policymakers are trying to come at this problem in a variety of different ways. On the designer side, people are, they're designing buildings with lower embodied carbon and they're looking for strategies and they're also looking for some data to understand where their building is as related to other places, as related to other buildings in the country and the continents and in the world. Policymakers are trying to understand what levers they can pull to basically say, how can we reduce this embodied carbon? And right now there isn't a ton of data out there, at least in an open source format or in a like compiled and easy to understand format. And so this study is kind of building on the first study. In 2017, Kate Simonen and a couple other people at CLF and in other places, I think in my MIT, had collected a lot of buildings, like over 500 buildings, and benchmarked them, released data, had a little dashboard for it. The problem is that like if you dive into that data, the scopes, right? What type of building it is, what type of life cycle stages are included, where it is all like kind of jumbled. It was just a reflection of the data that was available at the time. And so what we did is we sought out to update this data set and update our processes so that it was more robust and people could use it. And uh, and so our goal was originally to collect 200 projects, 200 real world building projects, and benchmark them. So what did we do? We had this kind of long process, and honestly, really exciting one for me. I started and helped develop some of the methods alignment here in the second thing. But basically, what we did is we had data acquisition and data preparation. So we would talk to different partners, different data contributors is what we called them. We basically would interview them and say, hey, would you like to submit to this benchmarking study? Here's why it's useful for the reasons that I just described. Here's what it would take. It would take, filling out this pretty extensive Excel spreadsheet and then submitting raw whole building LCA outputs from either one click or tally. Um, and then, so we met with over 40 firms, and then in total, we ended up only getting data from about 30 of them. From there, they filled out the information about their projects after, signing a data transfer and use agreement and ensuring confidentiality throughout the process in terms of what we were going to publish and what we were going to do. That was like a really big portion of it was kind of assuaging any fears of your building being able to be identified. Um, so after we went through that whole kind of very squishy kind of interpersonal portion of the project, people submitted data, which was really exciting. Like I said, 30 data contributors submitted over 400 LCA models. So what that means is that we got new construction projects, renovation projects, tenant improvement projects, but we also got baseline models, design iterations, and the actual proposed models. So we sifted through a lot of that data. And what my job was for a year was pretty much creating a process for taking that data from two different whole building LCA tools, one click and tally, and then also cleaning up the spreadsheet that we created to create essentially a data set of features and environmental impacts that we could then turn into some sort of final data record. When all was said and done, we ended up with 292 final projects, which was way more than our 200 um, building or 200 project goal. And we had a data set that is really robust, really exciting, and I will talk about a little more here. So there's a ton of outputs from this. I'm going to go through some of the papers really quickly. We have the California Carbon Report, came out about a year and change ago. It was an analysis of just California buildings specifically, so we had 30 buildings there. The Embodied Carbon Benchmark Report that I'll get into, and then two other papers that we just submitted. Exploratory data analysis of the whole building LCA reports, which is kind of more of a deep dive into some EDA of the data set. And then material use and embodied carbon intensity, which is a really exciting one. These two are done by two people at the University of Washington. And basically the material use and embodied carbon intensity one is mostly about material use, honestly, and it's about like where, what materials we have in the building and what they are and how much they contribute to embodied carbon and also just mass. Um, the open access data set, just to go over that really quickly to understand what it is and why it's kind of unique. It's comprised of two, we have them in Excel spreadsheets, but if you think about them, two databases. The first is kind of a summary of all the projects. So it has every project is like a row, and that project has a whole mess of metadata, right? When I say metadata, I mean just any kind of information about the building, where it is, if it's in a location with enough projects, it'll also say the state. Um, it'll give you information about like what the building is, what its gross floor area is, if there's parking, if that parking has floor area, um, structural systems, information about facades like window wall ratio and um, thermal envelope area. And then we also have some information about what scopes are included, what structural systems are included, and information about like the LCA done itself, like what phase of the building it's in, when the LCA was done, its completion year, stuff like that. Then we have another data set that essentially links based on like the project ID. So if you think about that one data set that had one row of data, there's another data set um, that has all the corresponding information about its materials and its impacts. So what that means is that for say one project, there is all of the life cycle stage, like all the environmental impacts of say one piece of rebar that was modeled. Um, and then that basically goes for every material and every element in the building. And so there's like a really rich amount of data about what is composed of, like what is comprised, this building is comprised of, down to the material level, down to the life cycle stage impact. So you can do a whole variety of analyses based on this, right? As you can see, we can do material use intensities, we can do embodied carbon intensities, we can talk about so many things that like I'm only going to scratch the surface on and that I'm really excited for people to work on in the future. So now that I talked about the data set a little bit, let's talk about the embodied carbon benchmark report, which is the focus of this talk and our kind of the culmination of all the work that we've done. Oh, one more thing. There's a couple of dashboards out and another one that I'm going to show you later. There's the dashboard. They're both on the University of Washington side, but they're these dashboards that like kind of just visualize the data set in a variety of different ways. I can give you guys the links afterwards. I don't have them on me right now, but they are nice little URLs and stuff. Okay, so let's talk about this report. Okay, the report sets out to answer some of these like pretty important questions, right? Like what are the high, typical, and low embodied carbon intensities for um, different projects, or even your typical North American project. You can obviously do this in a bunch of different ways. We will choose building use type as the main way that we will display that information, but there are a lot of different ways to visualize that data, and we want people to understand what they are. What is high, typical, and low. Um, what benchmark values are useful for these kind of policies, right? Kind of getting at the policymaker, how can we help people create benchmarks for policy? Um, Additionally, we want to know what are the most significant contributors and what project level characteristics are important to understand where in your building the embodied carbon impacts come from. And then what are some limitations, next steps, and stuff like that. So let's talk about embodied carbon budgets. There are two main ways to approach kind of building level reductions. Um, and we will say that the first one is called a reduction from a baseline. This is where you have your proposed building, whatever, it may be, and then you model a second building and you say, this is our baseline and everything else that we do to make it better. Let's say we swap out certain materials, we change maybe the grid, or we change some aspects of the building design in order to show that we've done a reduction. We've like displayed a reduction in uh, environmental impact. That's kind of a reduction from baseline. LEED is the big example of that, right? LEED was where you're going to find, I need a 10% reduction in 3 different environmental impact metrics in order to get my certain LEED credit. There's another option where you have just a straight number, right? And you say this building must be below a certain number of embodied carbon intensity, right? That's what ECI stands for. And this embodied carbon budget will say this is my limit, so whatever my embodied carbon is divided by my my gross internal floor area, my building's impact has to be below that number. And so with these two different ways of doing it, there's an and or approach. Some places will say, you either do the reduction from your baseline or you do a reduction or you stay below this cap, right? CalGreen is an example of an or. There are different pathways in CalGreen, right, that you can take. Or there's another option where it's and, right? You have to do a reduction from a baseline and you have to be below this certain budget, which is like ILFI is the big example for that. And so what we're going to be talking about is developing those embodied carbon budgets. We're not really talking about the baselines here, which is like a different topic and a different discussion. This is what is that number that we need to be below. So in this data set, here are some scopes and methods for you. So just like here's what's included in it. So for the embodied carbon budgets, these are new construction projects with their reference study period, RSP, as 60 years. Our reference unit is going to be embodied carbon intensity, and this is normalized by GFA, not so that is not including parking. Life cycle stages are A1 to we have like a bunch of different columns here for the different scopes. We have A1 to A3, A1 to A5, which is including construction and transport. And then we A5 was estimated. It wasn't something that came straight from the tools. We were able to estimate it based on having that material level data and using some reference values from the draft ASHRAE 240P. Um, Finally, some other life cycle stages we included cradle to grave, so A to C, with and without transportation. We excluded B1 and B6, mostly because we didn't have the data for B1 uh, readily available to us, and we didn't have like quite enough information to be able to do that. And we were not asking for whole life carbon, so we don't have operational energy for a lot of these buildings. I think that's a limitation of this, but something that we could look to do in the future. Um, the exciting thing is that we have multiple physical scopes as well. So we have structure and enclosure, but we also were able to estimate interiors for all projects, all new construction projects, based on the interiors that we had in our data set. Finally, we excluded biogenic carbon. The tools handle them differently, and it's just better to have an understanding of this like fossil, CO2 fossil, I guess you could say. Okay, so where does that put us? We have 239 projects that are suitable for these benchmarking comparisons. Most of these projects are multifamily residential, office, and education. They come from the West Coast. Shout out. Um, Most of them are pretty low, like in terms of stories above grade. They're usually 2 to 5 stories or less. And they're mainly comprised of concrete, steel, or some hybrid of concrete and steel. Um, so before we get any further, let's talk about a box plot. We have a lot of box plots um, in this report, and we do have like a nice little refresher on how to read a box plot in the report as well. So I just took this here from our report. The important things to note are the median and the mean, right? The median is going to be that vertical bar. The mean is an X. Boxes are created by quartiles, right? So the extents of the left extent of the box is going to be the first quartile, which is 25th percentile of the range of data. And then the third quartile is going to be the 75th percentile. Um, the difference between the third quartile and the first quartile is called the interquartile range, and that's used to find outliers, right? Everything 1.5 times the IQR is, anything in that range is not an outlier. Anything outside of that range is considered an outlier. 1.5, I had to learn this because I was talking about box plots so much. The reason 1.5 is used is it's about 3 standard deviations um, from the from like the median. Um, I say about because it's a little more than that. I think the real number is like 1.2 something, but 1.5 is just like easier to understand and is in statistics mostly about just being able to convey this information. So they chose 1.5. That's our interquartile range. That's how you get outliers. Um, that's what you should be looking at for these box plots. Okay, so this is what we provided for, this is like a good example of what we're providing for these embodied carbon budgets. We created a like kind of reduced version of all of the building use types that we had in the data set. So other types is kind of collapsed. Public assembly is collapsed, and I'll show you the full extent of these use types in the future. But like we chose these because they're very similar projects, and they operate kind of in the same use type. And this allows us to have very good representation for each of these categories. And so these are the box plots, and this is the basis of the data that we'll have in the set of tables that we provide in the report. And so this is the table that we show in the report. This is our main set of embodied carbon benchmarks and budgets. So starting from left to right, right, you've got the 75th percentile, the 50th percentile, and the 25th percentile. 75th is easier to achieve, right? 25th is like, best practice or even like, kind of low embodied carbon. And then 50th percentile, the median is like your typical. We have all those collapse use types that I explained before. And then we have a variety of different life cycle stages, right? You have A1A3. If your policy is just using A1A3, here are the numbers for these different use types. If we're talking about upfront carbon in certain places around the world, this is kind of standard using A1 to A5. And so we have all of these options. And then we have like cradle to grave, life cycle stages, like I said, with and without transportation if you need it. We also have, like I said, the SE scopes, right? The structure and enclosure, and structure and enclosure in interiors, if that's something that you're asking people to assess. So this is the big table. This is found in our report. These are really exciting numbers. I, I don't want to, it is just a table of numbers. So sometimes when I step back, I'm like, this is kind of crazy that we're making a big fuss about this, but these could be really useful for making a bunch of different claims about your projects. And hopefully you'll be able to use this as either a designer or as a policymaker to be able to make kind of substantive change. Um, Applying these embodied carbon budgets, we also have some guidance on how to do so. There are a bunch of different things to consider when you're doing kind of a policy, or if you're thinking about how to get people to or what embodied carbon budget to use based on like what kind of program or system you're using. Um, this is mostly for policymakers, but the idea being like, there are different things to weight, right? Like, is this requirement voluntary or mandatory? Is it like, is it going to be a lot of projects or just like some of them? What type of approach you're using? Is this like an and approach or an or approach? If these kind of different things allow you to say, okay, I'm going to choose an appropriate body carbon budget based on whether or not, based on these different factors. Obviously, if you say I want people to use the 25th percentile, you want them to use like a more stringent number, and then 75th is like it's a little easier. This is like a just like a proposed way to say like weight these differently and think about these different aspects as you're creating your kind of your policy. I would say the report does a good job of explaining like what you would do, but at the end of the day, this is something that we're just like a suggestion, and we're hoping that people will be able to take advantage of this in the future and I don't know, give us some thoughts on how this worked and if it was helpful to have these different weights and stuff like that. Okay, so that was those were the budgets. That was the benchmarks. Those are the numbers that hopefully you can use to see where your building is compared to other typical construction in North America. I'm now going to talk about some of the other things that we took away from this data set, and this is just scratching the surface of the different analyses that you can undertake from this really rich data set. And let's do it. Okay, so let's talk about projects types is what we called it. But basically, is this new construction, or is this major renovation, minor renovation, or tenant improvement? Um, what we have here is that the majority of our projects are new construction. And then there were some renovations that we're able to get from our data contributors and we're able to put um, into the data set. Uh, One thing about these renovations is that they use a different normalizing metric than new construction does. If you think about it, like new construction is based on the new floor area, but renovation can be, you're activating a certain renovation area. You might be adding certain area as well. And so we had asked our data contributors to give us the area that was renovated and the area that was added if applicable. Major renovation refers to things, an addition, and minor renovation has no additions. Tenant improvement is obviously just like interior fit out. Um, so yeah, this is clearly showing, I think, that the lower carbon option is to be doing renovations, new construction. But we don't have like a ton of renovation data, so I don't want to. I think it's very like intuitive and clear to see that it's less of an embodied carbon intensity, just from the materials that you use and just from the, um, you know, just intuitively. But this does bear some of that out, and it's useful to see, I think, that like, renovation is supported by the data to be less embodied, like less carbon intensive. Okay, next, primary building use. So yeah, I wanted to talk about this again. This is different from our embodied carbon benchmarks because we collapsed some types. And so you can see some of the types that we collapsed here. Something like food service or lodging, transportation hubs, those things are not the same as what we had in the benchmarks. And so we turned some of those into others, or some of them into like different things like public assembly. Um, what should be taken away from this is that there's a large amount of spread for all of these building use types. Office and public assembly, they're pretty big spreads there, and I bet the standard deviations, I don't have them off the top of my head, but they're also very large based on that. So they're not super predictive of on their own when they're not collapsed. I think they're much more predictive when you use them as like in these collapsed building use types and have a better, amount of sample size. Uh, Ultimately, the median falls anywhere from 280 to 680 kilograms CO2 per meter squared. It's a really big spread, but that is at least something that we saw that was borne out in this data, and so would hopefully be useful as people are designing their buildings to say that's, irrespective of building use, this is what we're seeing generally in our data set. Let's talk about structural system. Wood light frame is coming out as the big winner here in terms of lower embodied carbon. Wood light frame is usually like the way that SE 2050, which is what we use for structural information. They're like their fields. We just lifted it from them. Thank you, SE 2050. Wood light frame is joists and sheathing typically. Like wood shear panels. Kind of stick frame building if you could if think about it another way like that. Um, and so these projects are pretty low. Um, but one thing to note here about all the different structural systems, this is something that I think was really exciting for Brad and I think for me too. But um, our team really liked that there was a big spread here for these different systems because it shows that any of these systems can be low carbon, right? Just because you have a concrete building doesn't mean that you can't make steps to reducing your embodied carbon. Just because you have a wood building doesn't mean you're automatically going to be a low carbon project. There's still a lot of ways for you to decarbonize. Still a lot of ways for you to reduce your embodied carbon in your system, which is, I don't know, brings a little bit of hope that like there are ways for you to do this across the board. And even if you're, locked into a material that is typically considered like higher carbon, maybe like concrete, then that doesn't mean that you can't find ways to reduce. Um, well, let's talk about physical scope. Uh, this is based on OmniClass, which I don't know if people use frequently. I only really started using this as I got to CLF. It wasn't something that I was super aware of in practice. But there's a classification system for how you what building elements are. This is different from materials, which are classified using master format. I think that's what it's called, like the O3 whatever is for concrete, O5 is for metals. This is more based on like what is the building element, where does it live in the building itself. And so what we're able to do was use information that we like data from the materials themselves uh, to be able to sort, where they were in the building. This was a pretty intensive process in our data cleaning procedure. We basically had to create a whole system of rules for how, um, what types of materials, what types of elements, um, go where in a building. And so I'm really proud of this. This is a lot of work with our team, and we're able to create metrics for building elements and where they live in the, where elements are in the building. You would think that this would be easy because these were all modeled, in a, in BIM, but uh, that information is not totally available from the tools. The tools do give you, their where they think the element is, but if you don't model it correctly, and sometimes people didn't necessarily, put in the right metadata, um, that information wasn't readily available. So we had to kind of adjust that. Um, what you see from these graphs is that structure is the majority of the embodied carbon intensity in a building, followed by enclosure, and then followed by interiors. Um, and that should make you think, okay, structure is like the most important, but interiors and enclosures still do contribute a fair amount, to the building. And I think it would be wrong to say that like you should only focus on one of these. Interiors can end up being very large, and I would say I would not be surprised if we were undercounting some of these interiors, not because um, people modeled it poorly or something, but it's just like there aren't as many standards on what exactly should be modeled. And we tried our best to, filter out projects that weren't, doing as much interiors as they maybe said they were. But at the end of the day, I think this is something that might change over time. Let's talk about building materials themselves. So what we're able to do with this data set is we're able to also find out how much of the materials are contributing um, to the total project's embodied carbon. What you're going to see here is that concrete and steel account for the largest amount of embodied carbon in a project. The thing to note that's kind of tough about these graphs, and the thing that's like really interesting to understand, is that not all projects have all of these materials. And so this is an average of the projects that do have these materials. And so, um, it's still important for you to understand, what this is on a per project basis. And like it's hard for us to extrapolate all the time for every project and every building, because not all projects have, like synthetic composites or acoustic ceilings. And so, but when they do have it, here's their average contribution. Anyway, these are the top 10 materials on the left. You can kind of see the top five for me are, are the most frequently occurring are concrete, steel, insulation, gypsum, and I think aluminum. I think it's on the next page. Um, but there's a lot of insights that we can glean from this, and I think I'm really excited for us to be able to do that more in the future. Or at least, see other people start to dive into that. Finally, we are able to talk about material use intensity. We again, I would suggest that you look at there's a preprint available for that material use intensity paper, and that is going to dive in way more than we did and way more than we were able to. Um, Material use intensity has a lot of information that's like very complex to get into as well, because like I said before, not all buildings have all the materials. And so the way that you categorize that data is like really important. Are they zeros or are they not, in the actual data set? And this kind of information skews medians, means, and stuff like that. So Malad Ashtiani is the guy who wrote the paper on the UW side. He has really good insight on like why that's important and um, how you should, view this data. He also's got a cool dashboard. Anyway, let's talk about the material use intensities that we can show very easily. Um, and what you'll see is that concrete, oh, this is also a log scale. It's not even like linear. The concrete material use intensity is way higher than the rest of them, right? This is in the order of like 1,000 kilograms per meter squared. Whereas the next best one is probably, or next highest one is steel at probably 100. So concrete is heavy. Concrete is heavy and it is abundant in all of our, projects. Steel is in everyone, but concrete is in pretty much everyone minus one. Um, and yeah, these kind of things are really uh it's really interesting to see like where these materials line up, how heavy they are, and like their masses relative to other projects. Right. Okay, finally, uh, this is something that SE 2050 has also borne out, um, and I think it's a really interesting and good thing to constantly reinforce. Basically, using less materials is a key strategy to reduce embodied carbon in buildings. That's I want to bold that, highlight that, underline it, whatever. Um, when we talk about mass in relation to GWP, there's like a pretty strong correlation there. And then when you talk about material use intensity to ECI, there's kind of a correlation there. The most important thing is like materials to total GWP. And like it's super intuitive, I think, right? Like I think if you use more material, there's going to be more environmental impact. Um, and so I think that's like a really big takeaway for me. It's been a big takeaway for me and will continue to be a really big takeaway for me um, as we talk about different reduction strategies. So what are our takeaways here? Um, Generally, median values for every use type are between 280 and 680. Structure accounts for the majority of the building, and wood light frame is the lowest ECI. Concrete, steel, gypsum, insulation, and aluminum are the most common materials, and concrete and steel have the highest average MUI and ECI. And then finally, uh, less materials equal less environmental impacts generally. Um, cool. So that's the embodied carbon benchmark report. Time is it? Okay, I got like 5-ish minutes. Um, I want to talk about another project that I've been working on that's obviously very related to this. Um, I have been working well, like as my first project at CLF-HQ. We had this weird like nonprofit thing, but I was like kind of the last ish to move over. So this is my first like CLF-HQ project, which is nice. I have been working on this dashboard that furthers the functionality or like really lets you dive into the data set. Um, this data set can be pretty intense to look at. The um, the one with just the metadata in it is 292 rows, obviously, which is not so scary, and it has some summarized environmental impacts. But if you want to dive into the material level data, that is 900,000 rows, more than 900,000 rows. Actually, I think it might be more than a million. Um, it's very heavy, right? There's just like a lot of information there about every material that is modeled for every project, for every life cycle. Um, and so we have a lot of data to share. So it's not totally intuitive how you would go about doing that. And we don't want people to have to like, it's not easy for designers to find a lot of time to crunch these numbers. So we wanted to make a tool that would make that possible. Um, so diving into this benchmark explorer, um, what you can do is select impacts, right? I have the ability to check material use and all the other um, environmental metrics besides embodied carbon or besides global warming potential, but we'll stay there. I can do impact intensity, right, which is divided by a um, a floor area, be it with or without parking, or I can show total impacts. Um, I'll stay on impact intensity now. Uh, we can show whatever life cycle stage combinations we would like, and the data updates automatically. So if I just wanted to see A1, A3, and C2 to C4, why you would want to do that, not sure, but if you want to just look at end of life, you can do all these things. We can also see interiors included or interiors excluded. We can just look at superstructure, um, or just structure itself, substructure and superstructure, or say enclosure. Um, let's stay here. Let's say you didn't want to do new construction though, and you wanted something like all of the renovation projects, you could look at these as well. So there's a lot of different nuance that we can do there. I'll collapse this. Um, I can look at all the projects, or I can start to filter them based on something like primary building use type, or something a little more structures friendly like primary horizontal gravity system. Uh, and then this is where this dashboard goes kind of crazy. I don't want to overwhelm you. This is just what we're able to do, and it's really exciting. So hopefully you'll find this super useful. Um, let's say you wanted to filter, right, all the horizontal gravity system. You wanted to filter to just concrete, let's say these non-PT framing. You could do that very easily and now see all the different impacts. Um, and we want, let's just do A to C. So you have all these different impacts, right? But wait, there's more. You can do this by a second categorical variable. So let's say, for example, I wanted to see what about parking for these guys? Well, some of these projects have parking, some of them have below grade, some of them have no parking, some have below grade, one has above grade. Okay, I have parking, but I just want to see the below grade ones. You can do that. Okay, well, maybe I want to see the below grade and no parking. Um, so now we can really dive into this data set and see the different options here, of which there are numerous. I think there's a lot of you can play with here. And then finally, material selection, I can see just the impacts from concrete. Let's say I want just concrete and steel. I'll just type in steel. So these are just the impacts for concrete non-PT framing with no parking for just concrete and steel. These are all the impacts for these projects. You have a lot of power with this data set to do these kind of analyses. And now we give you that capability. All of this information is kind of summarized here because I know it's like a lot to pick this stuff. So you can see what you're looking at. Um, there's a couple more filters here. Like I said, you can do your intensity by your floor area that has parking or does not have parking. I'll keep it with no parking. I would say I wanted to sort these boxes by median, right? The bigger to the smaller. Um, but a good example of this might actually be if I wanted to do seismic design category. Let's get rid of that. Okay, so right now this is sorting by median, which is useful, but let's say I wanted to see it by seismic design category A, B, C, D, E. Um, that's what this categorical value does. And then let's say I wanted to see it by sample size instead, right? I want the most sample on the most on the top and then all the other ones kind of below. You can do that. There are some outliers here. It doesn't change the calculations. This is just a visual crop. But you get rid of some of the outliers. And then my favorite is the reference line. Um, let's say you wanted to see where your project would be and where that would fall in all these benchmarks. You can draw a little line, give it a value, and then finally you can call it Mel's line. Yay, the end. And then this URL is big and scary because you can share all of this information with whoever you want, um, with what you've chosen. It's all saved in the URL. And yeah, so that is what we've been working on. That is what we've been trying to share with people over the last couple months. I think you've seen a flurry of all these great different resources. What we really want to do is provide as many people with as much information as possible so that they can make informed decisions about how to reduce their embodied carbon. Um, I hope you've enjoyed the presentation. Uh, really happy to be able to share all this information with y'all. Um, and yeah, let's dive into some questions.
Thanks so much, Mel, for that really amazing presentation and also showing us a really cool demo of the dashboard that you've created. I forgot at the very beginning to do a quick shout out for the other report co-authors, Brad, Aurora, Meghan L, and Kate. Thank you, team. Um, and now we have 10 minutes left for the Q&A. We got a couple of questions coming in. Um, for some housekeeping rules, please keep your questions brief so we can get this discussion going on. Our first question is by Rory. Rory, did you want to unmute and ask your question?
Sure. I was just wondering for when the GWP is broken down into material categories, if concrete is reinforced concrete or just plain concrete, and then all the rebar associated emissions are lumped into the steel category.
So let me pop up in the data set just so I can show you. The short answer is it is not, the steel is separate,
Yep.
um, which is great and not something that master format does, which is a little frustrating. That's like kind of been our issue with that. And so let's do full LCA
Yeah,
results.
that's cool. I just wondered when I'm using these as reference values, whether I should be including the reinforced version or unreinforced. Yeah.
Yeah, in the dashboard, it's not totally possible because, and I'll show you in a sec why that is. Basically, there's two levels of material data available for you. So this is what the spreadsheet looks like. And so I have here, oh, this is the, sorry, this is the tally material group. So you got two options. You got column C is material group. So this is what I'm showing in the, when I'm doing the material filtering, right? So if I want to look at steel, that's steel, but steel has a bunch of options, right? There's steel sheet, rebar and reinforcement, hollow rolled, hot rolled sections, HSS, decking, and stuff like that. It was a little too much information to put in the dashboard to have this material type, but
Yeah.
you can get material rebar and reinforcement if you do your own calculations yourself. We have all that information broken out, which
Yep.
is like not super doable with master format, right? Like usually that gets lumped in with concrete, which is why we did this separate.
Okay.
Um,
Thanks. Thanks for
no
the
problem.
info.
All right, our next question is from Simon. We got a couple from Simon. Simon, do you want to unmute yourself?
Yeah. Hey Mel. Fantastic dashboard, by the way. I love it. Um, the one thing that surprised me early on in the presentation is there seems to be no discernible difference in the data between the distribution of embodied carbon in the mass timber data set from, let's call it, more conventional construction methodologies. And I get you left biogenic carbon out of that, but was there anything that drove that? Can you speak to that in more detail?
Yeah, yeah. Honestly, I think this is something that we'll probably do like a longer blog post about. My hunch is like there are several factors, and I will say that I've dived into this a little bit, but I have not done a full like analysis of why that is. I would say there's a couple reasons. One, um, we're talking about mass timber, not stick frame, right? So mass timber
Mm,
is going to be, um, by its typical design, a little heavier, right, than your stick frame design. A lot of mass goes into mass timber, and I would bet that some of these projects have some pretty big grids because that's what we're used to. We're used to pretty big grids and we want to see, that open space. I would assume that the beams and the decks are pretty thick, right? So the mass that we're using in the timber would be more than the mass that we're using in steel and concrete. I mean, we've been iterating on efficient, steel and concrete members for at least over 100 years now, and our mass timber, we might not, be doing that at the same level. Um, Another thing that would go into that is that a lot of these projects have a lot of concrete in them. And so either they're modeling them as concrete, and that's what we have to work on, or they're not using something more like a lower embodied carbon, maybe like a gypcrete or something, for that fire resistance. Because what'll happen is a lot of these timber buildings will have a 3-inch concrete topping, that is doing a bunch of different things. It's protecting the deck on one side for fire. It's also doing a lot of like damping for acoustic and like vibration issues. Um, and so what we saw is that we saw these buildings still have a ton of concrete in them. And so we're able to design these buildings, with timber, but they still have a lot of mass and they still have a lot of, um, concrete in them. I hope that, we're able to reduce that and start using lower carbon kind of solutions for those concrete toppings wherever possible. And like, the building is still going to be lighter than it is, than a concrete building. And so like that does trickle down to the foundations, but like, is that enough to overcome the additional mass that we're seeing? And so those would be my suggestion, or like my guesses as to why that is. I hope that we're able to put out some more in-depth analysis about that in the future, because I also find it very interesting.
Sounds like we need to figure out how to get rid of that concrete topping, doesn't it? But
Yeah.
I'll just hit my second question then. I mean, obviously the dashboard was fantastic. Ton of work must have gone into data collection and everything. Do we have a plan to continue populating the data set, or is this a sort of static data set that we're going to be referring back to for the next 10 years?
I hope it's not the only thing. I think we have been shopping around like, the idea of doing more of this. At the moment, this is a snapshot. I think we're really interested in continuing this. Just like from our team's perspective, like we have a bunch of like lessons learned on how to do a lot of this data analysis better and quicker. Um, mostly in terms of efficiency and like how we could do this kind of, again and faster. And so um, I would, I believe that we're going to be creating some sort of like rolling database in the future, but I don't know when that is, and I don't know when that'll be funded. But I think it's the goal. At least that's what has been communicated to me internally. Um, so I don't want to promise that it's going to happen tomorrow because I don't think it will. But I'm hopeful, at least as long as it's like it's something that is like high up in our list.
Cool, thanks.
All
Hey,
right,
Luke.
thank you. Oh,
Oh,
Luke.
go ahead. Yeah.
Sorry, were you gonna add something else, Sandy? Um, yeah, thanks, Mel. This was great. Um, I have, I guess, a couple quick questions. One, yeah, first off, echoing Simon's sentiments, like this is a great data set, and I feel like even just you kind of playing around with the dashboard there, there's lots of kind of side studies that I imagine are either in the works or that we could kind of dream up. So that might be one thing. I mean, more of a general question for like this group and CLF-LA is maybe how because I can imagine everyone like going off and uh, doodling with it themselves, but it might be useful to structure some kind of way to share those studies, like even thinking about like rebar rates in the concrete and how that impacts things. To me, that's more of a general question, but my specific question was actually going to circle back to the bridge behind you, which was those material use intensities. Um, and I wonder what you think, and maybe this is also a little bit of a spicy topic, but one of my kind of pet peeves is we still are kind of banking most of our embodied carbon reductions on just procurement of materials and haven't really pegged the like material efficiencies. How do you see those kind of material use intensities being applied in the future? And do you think there's any potential for kind of like requiring a certain optimization, or is that, I don't know, too constraining to design professionals?
I haven't really thought about it like that. I have not thought about our material use intensities being a like budgeted metric, right? But I don't see a huge reason why I wouldn't. My first thought would be that the the spreads are a lot larger than they are for something like primary building use, and we've been doing a lot more embodied carbon research and a lot less material use intensity. I personally would be really interested in like getting more data. Um, just because like I think they're dependent on a lot more things than I mean, I guess embodied carbon is dependent on a lot of information as well, but I just have less of an intuition on material use than I do for embodied carbon. Um, I think, yeah, I think that would be something that people should think about pursuing in the future. I haven't thought about it as a lever for using for efficiency, right? I guess that's what we're trying to get at, right? Is like less materials equals less, environmental impacts, which is like a big takeaway from this. Um, I think that'd be really cool. I would think that the better group to do that would be SE 2050. If you know the person in charge, that'd be great.
Yeah, I mean, I've definitely thought about even just using it as like a way to show clients like where they fall and what
Yeah, I
they're
mean that's
ultimately
definitely
paying
possible
for.
with
Yeah.
that's possible with our data set for sure. And I think that's like that's kind of the I think even with the dashboard, I think you're able to do that. Material use is one of the metrics. That has just not been high on my personal like what I've been looking at list. I think it's very, very smart.
No, there's so much that I think could come from this. So thanks for sharing with the group, and I'm sure Sandy, you probably want to wrap things up, and everyone's got to get to their calls.
Yeah, I just want to thank you again, Mel, for this really cool presentation and all your work on creating this game-changing benchmark report. And thank you for everyone for joining. And we hope that this will be of use to you. And we hope to continue this discussion. Looking forward to next month, we'll have a How It's Made webinar for certain materials. And look out for our postings on that. And looking forward to the end of the month, we'll have the Towards Zero Carbon Summit by Luke. And you'll if you haven't registered already, you'll just hear the download on LinkedIn at the end of this month. All right, that's the wrap of our webinar. Thank you so much, everybody, and thank you, Mel, and we'll see you next time.
Thanks.
Yeah, thanks, Mel.